how do we tell these different kinds of matter apart? Well, one way is to look at physical and chemical properties. Different substances have different properties, and there's two basic types of properties. A physical property is one that a substance displays without changing its composition. So these can be observed without changing what the substance is. So mass would be a physical property, color, density, hardness, those sorts of things. A chemical property is one where the only way you can observe a chemical property is by changing the composition of a substance. And so when you demonstrate a chemical property, you end up destroying the substance that you're looking at. So examples. The characteristic odor of gasoline is a physical property. By smelling the gasoline and noting its odor, you do not change the composition of the gasoline. And it exhibits its odor whether you're there to smell it or not. The flammability of gasoline is a chemical property. Gasoline burns. When you demonstrate that property, when it exhibits that property, it is no longer gasoline. It's converted into carbon dioxide and water and some other stuff. Okay, so chemical property versus physical property. So if we're looking at the particles, the atoms or the molecules, the composition of the substance doesn't change. So the boiling point of water is a physical property. Water boils at 100 degrees Celsius. When you boil water, it goes from a liquid state into a gas state, but the individual particles stay the same. Just like when we dismiss class and you go from, you're actually going to sublime, you're going to go directly from the solid state into the gas state. But individually, the students are basically unchanged. You're still yourself. You don't change into somebody else. When water boils, it changes from a liquid to a gas, but the particles are still water molecules. So anything where we have a state change, boiling, freezing, condensing, melting, subliming, anything like that, it's still the same substance. Here's a picture. Here we've got a pot of water, and here's the water in the liquid state. The particles are close together. You heat them up and they boil and they go into the gas state, but the particles themselves don't change. They're still water molecules. So a physical property is the boiling point. We can demonstrate the physical property without destroying the substance. Chemical property. Iron rusts. This is a chemical property because as you demonstrate the rusting of iron, you destroy the iron. So here's a nail, and pure iron is going to be iron atoms, and they're all arranged nicely. It's a crystalline solid. When it rusts, it reacts chemically with oxygen, and the oxygen comes in here and gets in with the iron, and it's not the same stuff anymore. It's iron oxide. And iron oxide is not nearly as strong as iron, is it? The rust is just going to flake away and break and cause the floorboards of your Mustang to have big holes in them. So, example. Distinguishing physical and chemical properties. So determine whether each of these properties is physical or chemical. The explosiveness of hydrogen gas. That's going to be a chemical property. So what clue are we looking for in that? Well, explosion implies burning. The bronze color of copper. That's a physical. Anything relating to just the color of it. The shiny appearance of silver. That's physical. Silver being shiny doesn't cause it to not be silver anymore. Hydrogen exploding causes it to not be hydrogen anymore. It ends up being water. The ability of dry ice to sublime, which means to change from a solid directly to the vapor. That's physical. That's a state change. Any state changes are physical properties. Anything that's a chemical reaction, explosion, burning, those are chemical. Any questions? So state changes are always physical changes. And by state change, we just, we talked about solid, liquid, gas. We mean changing between those states. Question?
So what about like mold?
Mold.
Would that be a chemical?
When something gets moldy, yeah, that would be a chemical change. Because what happens is the mold is growing on the substance, and so it's actually decomposing the substance. Any other questions? Some of these, identifying some properties can get a little fuzzy, and we could argue some of them. I'm not going to ask you any of the fuzzy ones. I'm going to ask you obvious ones. So I wouldn't ask you about, like, bread getting moldy. It's interesting to talk about, but it won't show up on an exam question.